So let's establish or prove the identity cosecant of x times tangent of x equals secant of x. The first thing I do is decide which side I'm going to start with. And the side that looks more complicated is the left-hand side. So I'm going to write that down, and then I'm going to put an equal sign. I first ask myself personally, is there any algebra I can do to simplify this? But no, there's not. So then the second thing I ask myself is, are there trig identities I can use on this? And yeah, there are. Cosecant is 1 over the sine, and tangent is sine over cosine. Now there's some algebra I can do to simplify. These signs cancel. That leaves me 1 over cosine, and our reciprocal identities tell us that that is the same thing as secant. So notice I started with one side, happened to be the left-hand side. I put equals between my steps because I'm claiming that these things are the same as each other. And my last step is equals the other side. Let's try another one. Let's show or prove that this sine squared of minus theta minus cosine squared of minus theta over sine of minus theta minus cosine of minus theta is equal to cosine of theta minus sine of theta. Again, my first step is to decide which side I'm going to start with and write it down exactly as it appears in the problem. I'm not going to do anything to it. Just write it down as it is. And now I'm going to ask myself, is there any algebra I can do to simplify that? And actually there is, but I prefer to start with using trig identities so that I don't have to deal with those minus thetas. Now, this is an optional step. I'll put it in green because it's optional. I just want to help you understand what this first expression means. Sine squared of negative theta means I have sine of negative theta being squared. And then I'm subtracting something. What am I subtracting? Cosine squared? Well, that's the same thing as cosine of negative theta being squared. And similarly down below, I have nothing really to do down there. I have sine of negative theta, cosine of negative theta. I'm going to put in one more optional step. Again, this is just to help you understand what's going on here. But using the odd-even identities, I know that sine of negative theta is the same thing as minus the sine of theta, and then that is being squared. And then I also know that cosine of negative theta is the same thing as cosine of theta, and that's being squared. And down below I have minus sine of theta, because that's what sine of minus theta equals. And I have minus what? Cosine of negative theta. Cosine of negative theta is the same thing as cosine of theta. So in other words, what I have is, so when I square out the minus sine of theta, that minus goes away. That gives me sine of theta. And then I have, and it's being squared, so I'll put the little squaring in there. And then cosine of theta squared is usually written cosine squared of theta. Down below, I have minus sine of theta minus cosine of theta. So if you want to jump from the first blue step to this blue step, that's okay. Now, what can I do from there? Well, I'm going to ask myself, is there any algebra I could do? Because I don't really see trig identities that are going to help me a lot here. So I'm going to say, yeah, sine squared minus cosine squared, I can factor. That's sine of theta minus cosine of theta times sine of theta plus cosine of theta. Now, I'm hoping to cancel with something in the denominator. And my denominator, minus sine of theta minus cosine of theta, doesn't match either of these factors that I've got on top. But notice I could take out a -1 down below, and that'll give me sine of theta plus cosine of theta in parentheses with a minus in front of it. And now I have things that cancel. I've got a common factor of sine theta plus cosine of theta. Those cancel. So at this point, I have sine of theta minus cosine of theta over -1. And I can bring that minus sign up front, which will give me minus sine of theta plus cosine of theta. Now at this point, I've honestly forgotten where we're heading. So, oh yeah, we want cosine theta minus sine of theta. Well, I basically have that. I just need to reverse the order those two terms are in, and I have my right-hand side. So I am done. Let's try another one. Let's establish or prove the identity cosine of x over 1 plus sine of x equals 1 minus sine of x over cosine of x. Now, to me, these both look equally complicated, so I'm just going to pick either one. I guess I'll start with the left-hand side. It doesn't matter. I could start with the right-hand side. But I'm going to write it down exactly as it is, and then I'm going to put equals and start doing stuff to it. First question, is there any algebra I can do to simplify this? No, I don't see any. Are there any trig identities I could use? Well, gosh, no, I don't really see any trig identities that will help here. So what can I do? Well, there's a trick that often works when you have a binomial either in the numerator or the denominator, and that is to multiply by the conjugate of that binomial. In other words, the same binomial but with the sign changed. And of course we have to do the same thing both above and below. That way we're just multiplying by a gigantic number 1. Let's see what we have now. On top I have cosine of x times 1 minus sine of x. Now I'm not going to distribute the cosine in, because with fractions I'm always thinking, oh, maybe I can cancel something. So I need factors. But down below, just writing 1 plus sine of x times 1 minus sine of x isn't going to help. In fact, I'll do this in red because it's not what you want to do. What people often do, so this is a common mistake, is to just write down exactly what you've got and then say, oh, I can cancel this 1 minus sine of x. And that's true, you can, but notice you've gone in a circle. You're just back to cosine of x over 1 plus sine of x. So this is what you don't want to do. Not because it's wrong, just because it doesn't get you anywhere. So instead, let's multiply down below. I'm going to use my formula that a plus b times a minus b is a squared minus b squared. So I have 1 squared, which is 1, minus sine squared of x. And now what? Well, I could factor that denominator and cancel, but then I'd just be back to this circular thing. Is there something else I could do that's not algebra, that's maybe using a trig identity? Well, yes, there is. Because 1 minus sine squared is the same thing as cosine squared. And now if I cancel, I won't just be going in a circle. So I'm going to cancel the factor of cosine on top with one of the factors of cosine down below, which will leave me 1 minus sine of x over cosine of x. And I think that's what I needed to show. Yes, that's what I needed. So I am done. Yay!